Hi, my name is Lorian Pratt. I'm Chief Scientist for a company called Quantellia. We're a software company based in Denver, Colorado. Today I'd like to tell you about a new kind of program management software called Decision Engineering for Enterprise Program Management, or DEEPM. DEEPM is specifically designed to address the complexities of very large programs with many hundreds, dozens, or thousands of interacting projects, each of which in turn contains many tasks, each of which in turn contains many milestones. The basic idea is that complex projects or programs like this have many potential points of failure. DEEPM introduces simulation technology in order to provide an over-the-horizon view to check the many interactions between the business rules that would determine if a project is going to be successful going forward. By doing this, we're able to detect and thereby avoid problems with those projects, thereby saving many tens of millions in unnecessary costs for a large program. This over-the-horizon view is necessary in particular for the longer term. Often programs do have clear analysis of the interdependencies between projects for the next month, 3 months, or 6 months, but the longer term is completely blind. Quantellia was able to save tens of millions of dollars for a large European financial institution. Our task here was to take this company's network of communications and data IT infrastructure and to transform that to a new cloud and voice over IP infrastructure. This company had over 10,000 sites in over 50 countries, and there were over 50 business rules per site. By transforming this infrastructure, this company was seeking to radically reduce its operational costs associated with communications and IT. However, this project was missing its scheduled targets, and every time there was a change to the schedule, the analysis was manual and required many months in order to determine how schedule problems could be avoided in the future. This resulted in substantial unnecessary cost, and by applying DEEPM, we estimated we saved over $10 million per year with an ROI of over 20 to 1. This graph shows how we were able to reduce the operational expenditures. On a transformation project like this one, again, our goal is typically to take high operational expenditures and to make some change, in this case the communications and data infrastructure, in order to lower OpEx. Now we can lower OpEx rapidly, or we can lower it more slowly, as shown in the blue shape here. DEEPM was able to rapidly reduce the operational expenditure, therefore increasing the business benefit of this project by reducing the overall costs during the course of the project. In general, transformation projects and complex programs in general have highly interdependent factors, creating the need to coordinate many activities in several organizations. Here we show finance, contracts, procurement, IT, real estate, regulatory, and in general there's many different activity categories that need to be managed simultaneously during a transformation effort. This number of interactions grows exponentially, and each activity is subject to many constraints: budget, contracts, leasing, business, contracts, regulatory, resource availability. All in all, the complexity of projects like these generates substantial program risks that need to be explicitly identified and managed. A simulation approach in which we can have a forward view of these risks before they occur is absolutely essential in order to optimize the costs of such complex projects. So let's take a look at the DEEPM tool itself. What we're looking at here is what we call the DEEPM Gantt chart view, where time is represented on the axis at the top, going from June 2012 in this particular example to February 2013, as you can see along the top right. Now importantly, this is just one visualization within DEEPM, and we can also very easily build custom visualizations to meet your needs, since DEEPM is built on our World Modeler platform. Within this visualization, you can see a number of rectangles. These are color-coded to show their status in terms of their risk. Risk is determined based on the likelihood that there's a rule violation, some reason that a particular scheduled task can't actually occur. Now each rectangle in this particular case represents a building that we're going to transform. Each building has a large number of tasks and also milestones, and is associated with several dozen business rules that determine whether this building can be completed on the date indicated. If you look at the right-hand side of each rectangle, that corresponds to a date, and that's the date at which we expect the transformation to be complete. However, all of these rectangles are red, and that means that each one cannot be complete by the date indicated according to our rule violation calculation. The DEEPM Gantt chart view allows us to experiment with various scenarios, changes to the schedule that might allow us to have a schedule that actually looks like it'll be successful. As you can see, I can move this particular schedule left and right across the calendar, and as I do so, the color of the rectangle changes from green in this case to red. I found a position here at which there are no rule violations. That means that we expect this particular site to be able to be transformed if we move it out 1, 2, 3, 4, approximately 5 weeks altogether. You can see as we move different sites left and right, a number of different violations are displayed. And we can see how changing the particular date of a site transformation introduces new and different violations into that site. The Gantt chart view automates the task of scheduling a large number of projects and programs and determining where we can put one in the schedule such that there are no rule violations. Now, what you can see is that I have a number of different new schedule times for these particular sites, and they're of transparent color. Their old dates have become gray. What I can do is click this Proposed Changes button, and that allows me to save each of these new locations so that this is a new schedule. Now I can save this back into a master plan such that tomorrow's data, when we draw it from an enterprise data source, will reflect the change in the actual schedule that I'm planning on accomplishing. For each one of these sites, we can drill down into the specific data about rule violations that occur within that site at the particular date at which we've scheduled it. So I'm looking at this 119 El Camino Real site. If I expand violations, I can see that for this particular location, I've scheduled the voice transformation to happen on a non-working day, a day in which people are not available. And this is the reason that this site doesn't look like it's going to be successful, and that's the reason that it's red. I'd like to show you one other feature of this Gantt chart, which happens if I click this Show Milestones button. The Show Milestones button provides a visual representation of key milestones within the transformation of each particular building. As you can see, there's a number of horizontal colored lines that are tailed back on the schedule behind each one of the site transformations. What these represent are the specific dates at which a particular milestone, if not reached, would create a rule violation, a reason that we think that that site transformation is at risk. In particular, a milestone that's not reached by the time of the colored stripe, the yellow colored stripe, indicates that there's a reasonable chance that the site will not be scheduled on time. The orange stripe is a stronger chance, and if the milestone still hasn't been reached by the time indicated by the red stripe, there's no way that this site can possibly be transformed by that particular date. However, if I've got a problem, as I showed before, I can move the site to a different time on the schedule in which it will be successful by our calculations of rule violations. By performing this over-the-horizon simulation, we were able to obtain a substantial benefit in the transformation costs of our reference customer. Typically, transformation issues impact a total of about 30% of the profit and loss and 5% of the total transformation expenses on a project that has approximately 5,000 sites or projects that need to be transformed. This 30% and 5% number comes from a number of sources. I won't go into the details on this slide, but let me just point to each one of the categories of problems that a tool like DEEPM that performs simulation can help to resolve. Number one, as we've talked about, anticipating and preventing planning errors in transformation activities allows us to avoid those errors, thereby substantially reducing problems with increased costs that we don't expect. Second, as we showed earlier in a graph, we can optimize our profit and loss scheduling. High-value, low-cost activities can be scheduled first, therefore achieving our operational expenditure benefits early instead of late in the project. Third, if there's changes to the project, we can analyze and create a new schedule much more rapidly with an automated tool like this. And finally, there's often many contractors and subcontractors on a project, and incenting them in a consistent fashion will help everyone work towards the same goals with another source of decreased cost and decreased risk. A final benefit of a project approach like this is to automate many of the project management office planning and analysis activities. Where can we use an approach like DEEPM? Again, amongst the many programs, many of them have a large number, dozens, hundreds, or thousands of projects with many hundreds of thousands of tasks. Today I've shown you the benefits of using DEEPM for transformation programs, but in general, DEEPM can be used for any complex program that has many projects in which a simulation of the future is going to help us to anticipate and therefore avoid unnecessary costs and schedule delays. In conclusion, DEEPM provides simulation-based program management. If we look backwards in history, we developed the discipline of program and project management many years ago in the 1950s. More recently, we have simulation tools that are used for many different tasks, but not so much program or project management. DEEPM marries these two technologies, program management with simulation, and it's been proven in a massive transformation project to save tens of millions of dollars. As I said earlier, DEEPM is highly configurable. We can change rules very easily without the need to write new software, and so it can be configured for many large program needs. Thank you again for your time. My name again is Lorian Pratt. Please feel free to reach out to me using the contact information shown here. I appreciate your time today hearing about DEEPM, and I'm delighted to answer any questions that you might have about how this solution might help with your program and project management needs.